Okay, so with these counting principle problems, sometimes you're able to solve it with a single principle, or a problem might be a multi-level problem requiring repeated application of one or several principles. Like the last one, you could have done using a repeated application of combinations. Other ones are more simple. You could just use one of these principles. So it also helps to keep in mind the technique of overcounting. So think, all right, am I counting things more than once when you're doing this? All right, on the next page, I have a flowchart to help you decide which rules to use: multiplication, addition, permutations, combinations. And I know it's not perfect, but it might help if you're stuck. All right, so first think, all right, how many sets am I dealing with? Am I choosing from one or multiple sets? And then think, if you're choosing one set, are repetitions allowed? That's sort of like replacement versus non-replacement. Well, it is. That's exactly what it is. All right, so, and then does order matter? So when you're choosing one set without replacement, and then that's going to be a permutation or combination. All right, then that you determined by if order matters. If you're choosing more than one set, like one set of digits to be the first number in a phone number, and then another set of digits to be you're choosing from to pick the second number, something like that, then that's when you can think about using multiplication rule or addition rule. So with this flowchart, you can use it or not, however, just it's there to help. Alright, now I'm just going to run through these slides, so you might want to pause at each slide before I give the answer if you want to play along at home and determine, is each situation, would it be best to use a permutation or a combination? Okay, so let's say you were selecting the order for a softball game. Should you use a permutation or a combination? So you pause the video now if you want to think about it. And the answer is a permutation because order matters. So if I lead off with Sophie and Nicole is batting second, that would be a different order than if I switched the two. Okay, now if you were selecting people for a dodgeball game, alright, would you use a permutation or a combination? So let's say you had 10 people and you got to select 5 people to go out there for a game of dodgeball. How many ways can you do that? Well, and this would be a combination, because in dodgeball, there's no positions. You just throw 5 random people out there, and if you mix those people up within those 5 people, it's the same team. So order doesn't matter, so it's a combination. Alright, example 3, ranking your 2 favorite musical groups. Alright, well this would be a permutation, because when you're ranking them, order matters. Your number 1 versus your number 2, if you switch those two, that's a whole different list. Alright, so rank is another word for order. Alright, combining 4 ingredients for a soup. Permutation or combination. Okay, a soup is just a soup. You just throw the stuff in. Order doesn't matter. Maybe certain soups the order matters, but so it kind of depends. But most, like a vegetable soup, if you just throw the broccoli in, then the zucchini, if you switch it around, it wouldn't make a difference. So order doesn't matter. Combination. Alright, determining the number of possible locker combinations on your locker lock. This is kind of a trick question. It's actually a permutation. Alright, the term locker combination is misleading. I respect the hustle, but when you say a locker combination implies that order doesn't matter. But if you have a locker lock, you know that if your combination is 17, 13, 35, if you do 35, 17, 13, it's not going to open. So order matters. So it's a permutation. So they should call it a locker permutation from now on. Alright, 2 more examples. At Matthew's Diner, an omelet can be ordered plain or with any or all of the following fillings: cheese, onions, peppers. How many omelets are possible? So I like this example because it involves multiple principles. Okay, you can have a plain omelet, or you can have a 1-topping omelet, or you can have a 2-topping omelet, or you can have an omelet with all 3. But you can't do multiple of those things. It's got to be plain, or 1 topping, or 2 toppings, or 3 toppings. So in this part of it, it's an addition principle. Now, the number of plains, well, there's only one way to do that, because out of the 3 toppings or fillings, you choose 0. So there's one way to do that. And then for the 1 topping, Alright, out of the 3, choose 1. So there's 3 ways to do that, either cheese, onions, or peppers. Alright, and then for the 2 toppings, well, you got 3 to choose from, choose 2 of them. There's 3 ways to do that, cheese and onions, onions and peppers, or cheese and peppers. It's a combination because order doesn't matter. And then 3, choose 3, there's only 1 way to choose all the toppings, so there would be 8 different possible omelet combinations. Okay, and then this last example could be done in a complicated way or a simple way. And I did these questions a very complicated way before I learned this little trick. That's why I'm ending with this one. Anytime you have a question, so let's read the question first. How many ways can you answer a 4-choice, so a multiple choice test, A, B, C, or D, on a 12-question test, and you can omit any questions. So let's say it's like the old SAT where if you get something wrong, you lose points. So maybe you don't want to guess if you don't know the answer. When you can omit something, think of that as its own option. So there's 12 questions. So that would look like this. Oh no, wrong button. Each dash represents the question. Now the first question can go A, B, C, D, or omit. So think of omit as its own option. So there's really 5 ways you can answer every question. So the answer to this question would be 5 times 5 times 5 times 5, 12 times. So the answer is 5 to the 12th. And the moral of the story is when you can leave something blank, just think of it as its own option. And that's it. Thanks for watching these long videos. Sorry, but it's all new stuff, so I'll try to give you less work for this assignment.